So let me talk about our mission first. So Facebook wants to make the world much more open and connected. The mission statement is really about sharing and building communities so that people around the world can add value in their individual communities much more than most. So having said that, what does it mean for the world population? So when you actually ask who's connected in the world, who's not connected in the world, there is not much data out there. So what we tried to do the last month was actually trying to understand where is connectivity. You can see that here is the globe, 2G, 3G, 4G, and where is it not? And you can see a lot of black spots in the world. Okay, so you can see this is our data, so China is probably more 4G data or 3G around than shown, but it gives you a first glance of like Africa, Indian subcontinent, Latin America, that there are a lot of black spots. So when we dive deeper and try to understand how does it actually correlate with the population, you will find that there are actually not many population density maps out there, especially of people who don't have internet connection. So we looked at, here's an example that is Madagascar, Mozambique, and South Africa. And we looked at what do we see as a Facebook, where are the Facebook users. We can do density maps. And you can see there's a lot of black spots here, just an example. So what we've done, we worked with our artificial intelligence division and combined it with satellite pictures and a lot of data that we tried to get. And we came up with a population map. And you can see here in yellow, oops, here in yellow, sorry for that. In yellow, oops, it goes away, it takes too long. So, but you could have seen, when you were very quick, that there's a lot of people, yellow, that are not connected. So how can we connect those people who are not connected? And we estimate, when you look at the world population, that about 3 billion people are not connected, for various reasons. We believe about 1 billion people are just not aware or don't attribute connectivity as a high value. Another 1 billion, we believe, just can't afford it. So they know it's around, but they just don't have the money to afford it. And another 1 billion just doesn't have the connectivity around. So 3 billion, around 3 billion people in the world, out of some 7 billion people, don't have the opportunity as we do. And so when we look at that, and we take our mission very seriously. We take our mission very, very seriously. You can see in the moment I introduce you to the projects we are doing. When you look at that, there's an opportunity for the world to get better connectivity. And I'm not just talking about better just having connectivity, I'm also talking about getting better connectivity. And that, of course, carries us further into the developing countries and developed world. So, having said that, this is an overview about everything that I'd like to talk today about. You can see we look at very, very different applications. We look at terrestrial networks. We actually look at I will talk about that in a moment, about V-band 60 gigahertz field trials we are entertaining. We are calling it, this you might have heard of Terragraph. We connect from the terrestrial world towards our UAVs, unmanned aerial vehicles. And those unmanned UAVs are connected via free space optics. We demonstrated 10 gig free space optics in very high altitudes. And then you can also see that we do something with satellites. We announced that we work with Eutelsat on that. I'm not talking about that today, but you can see all of those different areas and segments are here to connect people, either in very dense populated areas or very sparse populated areas like UAVs or even satellites. here we go. This is just another depiction. So I'm going to talk now, first of all, about our UAV program. So our UAV program is really, you can see, it doesn't look like a normal airplane, right? It is rather a very sparse, 42 meters long wing plane, whatever you call it. It actually looks much more like a boomerang. Wow, boomerang. So boomerang is exactly what we expect, right? It turns in the air and is actually very, very thin in terms of air friction. It is very light, even though it has very wide, very 42 meter span length. In addition, it's solar power. So you need to imagine that it kind of gains the altitude during the day, like gains potential energy and then loses it overnight. So it can actually stay, and we hope it will stay a couple of months up in the air. So those are actually, how does it really work in reality and how we envision it, is it works so that we have millimeter waves connecting towards the first UAV, and you have several UAVs flying, and they're connected with free space optics. Free space optics works because it's very high altitude, right? It's usually very dry and usually very consistent weather conditions. So we have, as I mentioned before, already demonstrated, I meant to mention it, 10 gigabit connectivity between those UAVs. And you can really see that we could cover a very wide area, probably with a dozen or a couple of dozen entire countries. Yes, you will not get the high-speed connectivity we are used to in the developed world, but you will get enough to get interconnections, to get fundamental communication going, and some light version of Facebook running. What else are we doing? So we looked at the latest technologies in base stations, and one of the big opportunities we see in the world is connecting people in this range of tens of kilometers from cities. So we estimate that about 97% of the world population is within or about 40 kilometers of cities or big cities. So this is where this is the opportunity for us, right? When we find ways of backhauling traffic from the cities to the suburb or even further, 40 kilometers, we have an opportunity here to actually connect maybe 97% of the world population. So we looked at the conventional thinking of single transmissions. And clearly, the more streams you have, the less throughput you have per user. And clearly, when we look at the opportunities that massive MIMO offers to us, we see that we can actually get a lot more throughput per user, and we could have a lot of other opportunities, so like spatial, beam steering, fairly high throughput, even in shorter distances or eventually longer distances. So we set out, and we will see that in a moment, to actually experiment with 96 antennas. So 96 antennas. I mean, I just find that personally, like, my physics heart is bumping here. Is 24 streams. We were actually able to do 24 streams and get a very, very high spectral efficiency. So far 71, we believe we can bump it up to 100 plus bits per second per hertz. This is really about throughput, several streams with sparse spectrum available, right? So that could be many applications in many countries that could really help connecting people a lot better than today. So this is the actually antenna array. You can see this. These are the arrays. We had a lot of base station processing in the background. And here are the client devices that we envisioned for rural operation. As you can see, this is a lot more an experimental stage than you would, assume, a product going to market. But we will continue driving this technology further, as we believe that it will close a gap that we see in terms of topology coverage in the world. So having said that, I will talk about something that's a lot more advanced in terms of field trials. So we looked at the world and figured out, what spectrum is actually available and mostly free. I'm not saying everywhere. It's like countries like US, Germany, UK. They actually have 60 gigahertz and give that for free. Clearly, the problem with V-band is there is this oxygen and water absorption. So you never will be able to really transmit far distances. So this is really an application. We look here for high densely populated areas. There are many countries in the world who have very highly populated areas that cannot get really fiber there. So we looked at this technology and really tried to really drive down the costs significantly, as well as try to work on some assumptions, also from a routing perspective and application perspective. And I will talk about that in a moment. So you need to imagine this is basically a connectivity, a mesh connectivity across an urban population, as shown and depicted here. We use very low-cost Wi-Fi features, and we also looked at things like distributed as well as centralized routing and cloud computing to optimize this traffic. In addition, we did IPv6 nodes only. We have actually announced what we've done in greater detail, and it is actually labeled under OpenR. We have basically taken a messaging framework called 0MQ and used that to distribute routings and routing protocols. Somehow it became not just a routing protocol. It actually is nothing anymore like a protocol. It's actually now what I would call much more a network application framework. This network application framework allows us to use routing as an application. But so we did also monitoring. So we did new fair balancing of traffic, new fairness protocols. It was actually fairly easy to roll out based on that messaging MQ0 MQ framework. And it's in the end of the day all IPv6. We are testing it right now, and this is our campus in Menlo Park in California, and you can see the meshed connectivity. All those poles are at most 200, maybe 250 meters apart from each other, and the idea is to get meshed restoration. Every pole is being reached by at least from two sides, right? So, and you can see that we built up, a distributed routing that's localized, but also a centralized routing that allows you to have the global optimization procedure. So we tested all of these protocols ourselves, and actually we look right now at using those in our backbone data center interconnect network as well. So it's just more depiction. You can see here one of those 1547 is like a multi-node pole where you can literally see how meshy that whole thing is. We actually need to learn a lot more about that. Like, I mean, we are testing it. It seems to work fairly well. We tested it with a gigabit or gigabits throughput meanwhile. But again, this is just the start. So we decided to collaborate with the city of San Jose to actually build that in downtown. and try how this is going to work. So let me talk a little bit about the purpose of those field trials. So we will not become an operator. We're not interested to become an operator. We believe that we need to build as a community an open framework on hardware and software that allows us to drive innovation and adoption much faster. So that's our way to just push the technology and the technical edge to a point where adoption is easy. And adoption can be done like everywhere in the world, not just here in downtown San Jose, but all over the world. And so that's how we explore and build new frameworks, also with the purpose to make installation, hardware installation, software, frameworks, applications a lot easier. But the purpose is clearly we drive connectivity, we drive bandwidth, we drive cost per bandwidth down, and we want to build a framework of innovation that allows us to really, really pull in technologies and experiences much, much quicker, much, much quicker. So one of the things we're doing is we build those open groups. One better known is Open Compute Project, OCP. We founded it some 5 years ago. It was really centered around data center technologies. Today there's like many working groups. We cover nearly everything around data center, from network storage, servers, etc. And for us, and I think for the community, it was a very successful avenue we've taken. We believe that moving forward, we need to do something very similar in the telecom infrastructure. So beginning of this year, the founding members, Deutsche Telekom, ST Telecom, Intel, Nokia, and us were coming together and founded TIP. And tomorrow you will hear an announcement about what is going on with TIP and where it is moving. So we are in the process of making some of that technology, if relevant, available to the wider community. We will open it up, we will collaborate with many, many more companies in the world and build an ecosystem. And always with the purpose in mind that we find an ecosystem to drive bandwidth to the world, to the unconnected. 3 billion people will have not even the opportunity to complain about internet and drive economic development to literally every part of the world in the most effective way. That's why we do all of these things, and thank you for your attention.
Thanks for the presentation. Very interesting. I was wondering if in sort of all the cases, really, you kind of in the UAV and the Terragraph and the MIMO thing as well, areas, I think. You sort of showed it in areas, but what's the actual end user device connecting to? And what, obviously a lot of them seem to be uplink challenge from the device.
Right.
Why the mesh seems all right, but what is the user connecting with?
Right. So can we go to presentation mode again, please? Okay. Right. So Terragraph, as an example, is a backhaul. So you basically connect multiple gigabits, right, to individual houses. So you basically have an Ethernet router there, and you get your internet connection into your house, right? It becomes so your end user device is a simple Ethernet box, right? Termination device. So it's not a handheld cell phone, right? On the UAV and others, so we expect, so we're still working on it, what it means, right? So as an example, the UAV is really about coverage first. It doesn't need to be a handheld device. It can be a stationary simple device, and we're still working on it, right? But we've tried to get the first biggest problem solved. As another example, ATIS right now, as you can see, is also more a fixed device that you would put as an either enterprise or in the middle city, right, or city hall, or where you then from there on get a Wi-Fi connection, right? So literally you bring the internet towards a town, village, city, or a few houses, and then from there on distribution should be a lot easier. So I hope I answered your question.
Just very quickly on Terragraph, you're using the pole mount stuff.
Yes.
Yes. Obviously, it's not a sort of a new idea per se.
No.
You've got your messaging framework and your routing algorithms and stuff. But is that enough of a benefit on what came before? Just, the biggest challenge with those systems is like pole mounting, and how people stealing, especially people who steal it, and all of that. It's more a challenge than the routing algorithm normally.
Right. So I totally agree with you in the sense that first of all, 60 gigahertz is being talked about for a long time. With all the advantages and disadvantages. I mean, advantages non-interference, disadvantages reach, right? Advantages licensed, non-licensed spectrum, so it's cheap, right? So, but nobody really has done it in the sense of giving it out at some point in time. That's the intention at some point in time, that we put it in the opening when we see it actually works, and actually drive down the cost significantly and the volume significantly out. So I kind of agree with the notion that 60 gigahertz, all these discussions are not new in the sense of like 5 years or so. I can't recall when, and maybe even earlier started. But on the other side, nobody really has done it, right? So in addition, we built the framework of an open application framework in the back end, right? That basically allows you also to run this network in the most effective and simplistic manner, right? So all of this together is actually what we consider a fairly powerful solution. The other thing is, as you just said, right, the pole handling, etc. That's why we go into field trials. Like, we try to understand how this actually works in real life. So we don't declare victory, right? It's for sure not easy. I mean, there's phase arrays, there's tolerances. Clearly, Symposium might not be the coldest place, but for sure a very warm place. So there's a lot of things we need to figure out ourselves. And we will, of course, share those findings with the community as we go up. But we see a very deep cost decrease in actually doing that.
Good, thanks.
What's the cost point you're targeting?
Yeah, we haven't published that, but yeah, we have done our due diligence, and I think we probably should, push me off the record, and then we can maybe talk about it. But we definitely have done those studies. Like, we have actually have team doing this, where we compare different options also for coverage, right? But we believe that this will be significantly cheaper for the many reasons I just said. From spectrum, just imagine you get a framework that is pretty open, right, and allows you to innovate, to actually sometimes also just getting it going, right? So in some of the countries, there's literally downtown, you can't lay fiber. It's just, and even if you do, it breaks, right? So sometimes there's not just, it's just literally the only technology as we discovered, right? And then cost is a factor, but it's not the only factor.
Will you open up both hardware and software?
So once we see that things are moving into the right direction, right, the intention is to actually allow an innovative platform around that. So that's why we are working collaboratively with TIP now to open up what makes sense.
What is the physical size of the box that's, I guess, current and target that's going to be on the pole?
Oh God. So I'm literally running every day across these boxes, but they don't look this size. So I don't know how many inches that is now, but if you want to, but we actually have published pictures. And you're of course invited to come over to Facebook and have a look at that. So because the parking lot is of course public and soon to be seen in San Jose. Those boxes were much larger to begin with, but they're actually now fairly mountable from my perspective. But we have to go through, as you ask, to actually validation process. Yes.
That's some sort of rapid for the connectivity from your base station to the
What do you mean proprietary? I don't know. I didn't, from where to where, sorry. So this is all, will be all open up. So we did some tuning in some areas, some Mac tuning, we did a couple of things that will be made transparent.
There are no questions. Thank you.
Thank you very much.